Today's lesson is on section 2.7, finding square roots and real numbers. We're going to work on, especially today, finding square roots. I know that first part says estimating square roots. We're going to work on that actually tomorrow, but first today we're just going to work with square roots in problems, in expressions, and also just getting the idea that when I take the square root of a number, whether it gives me, as I call it, a nice answer or not, there is an answer for any square root. Like there is some number that when multiplied by itself gives me that number under the square root. It just may not be a rational number. Like for example, here I have some square roots. Like what are square roots? We've been working with them a little bit this year already. Here's what square roots look like. This symbol would look kind of like a check mark over the check mark and then a line over the number. This means the square root of 49. And what that's telling me to do is, as I have down here below, it's kind of its informal definition. What can square roots do? They tell us what number times itself gives me the number that's under the square root, or under that root. So in this case, square root of 49. What number times itself gives me 49? In this case, that's 7. Same thing with this next one, square root of 81. What number times itself? That's another way we can kind of replace that square root. Think of those words. What number times itself gives me 81? Okay. In this case, that's 9. A problem like this, still saying the same thing, but there's a negative out front here. And all that's telling us to do is take the square root of that number and then make the answer negative when we're done. So like the square root itself, the square root of 100 is 10, but then the negative up front says make it negative when I find the answer, so negative 10. And then this last one here, square root of 63, and here's the ones we're going to kind of refer to also today. When I have the square root of 63, it doesn't give me a nice number. For example, next to it, very close to it, square root of 64, that gives me 8. But square root of 63 does not give me such a nice number. Square root of 63, if I punch that in my calculator, I'm going to get something like about 7.879. And actually, I don't have the exact number right on me, but I could probably find it here in a second. I do have a calculator handy. Square root of 63, just to be accurate here. Square root of 63 actually gives me, I was close, just about a tenth off there. Square root of 63 actually gives me 7.9372539 dot 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 and a bunch of other numbers after that. It's an irrational number as we've been working on. Again, one of the main types of irrationals we'll see when I take the square root of a number and I get something that's not nice, as I call it, like all these others were, rational, nice whole numbers, or integers at least. When I get something like this is an irrational. And there are square roots to other numbers that don't give me something obviously rational like this, so like square root of 63. So we'll take a look at some of those today. We can even punch those in your calculator. I don't mind if we round them off to the nearest tenth. For an answer like this today, you just say 7.9, and that would be good enough for me. But we can talk about some of these types of numbers too, and what happens when we run into them in a problem too. When I'm dealing with square roots in a problem, like something that I have to evaluate, as this problem says right here, evaluate, find the value for it. I have to think of square roots kind of like absolute value, at least like we talked about absolute value in the past. Think of it like absolute value, where it's kind of in the PEMDAS, in our PEMDAS acronym, it's like in with the parentheses. I have to find the square root of something before I can do the things that are around it. So like in this first problem right here, 10 plus square root of 25, the first thing I have to do is I have to take the square root of 25 to make this problem work. I can't go on until I do that. So this one ends up being 10 plus, well, square root of 25 is 5. So 10 plus 15, or so 10 plus 5 gives me 15. But I have to take the square root before I can do anything else. It's kind of like parentheses where I have to take care of that, and then I can do the things around it. Same thing with this next one. Okay, square roots comes before multiplication because I have to figure this out first. 6 times the square root of 49, which is 7. 6 times 7 gives me 42. Skipping down to a few other problems here. Same kind of thing though. When I have a problem where I have a square root inside of it, or inside the problem, at some point, I'm going to have to take care of that square root first and find out what that number is. We can also, this problem number 3 here, kind of like order of operations like we've done in the past, I can drop down the plus sign to remind me though that I've kind of broken this into 2 groups. The first group, negative 2 times the square root of 81. Square root of 81 is just 9, so negative 2 times 9 gives me negative 18. On the other side, I just have 6. So negative 18 plus 6 gives me negative 12 for this problem. And then that last one, I'll move my bar out of the way here. Square root of 196. over x, where an x is 2. So I'm just going to rewrite this problem so that my variable now has my number in there. I can just put 2 in for x like it says. Square root of 196 is 14. And 14 divided by 2 gives me 7. So again, any of these problems just kind of showing how square roots can also show up in a problem. We just have to take care of those first, just like a parenthesis. Also, again, dealing with square roots, sometimes we just need to understand like where they fit on the number line compared to other numbers. So like the square root of 13, it's bigger than 3 or less than 4, somewhere in that range. And obviously, again, when I punch that in my calculator, I can hit the square root of 13 in this particular problem. And it'll tell me what square root of 13 is here. If I get my calculator back out, it is going to be somewhere in between 3 and 4. Just where exactly, I want to know. Looks like it says about 3.6 for 3.6. I'm going to round it to the nearest tenth there. So 13 is 3.6. Negative square root of 5. Again, that negative just means make it negative when I'm done. Otherwise, I can find out what the square root of 5 is, which will be about a little above 2, I think here. Square root of 5 says it's 2.23. I'm just going to round it to the nearest tenth here, so negative 2.2 I'm going to say. Square root of 9 actually ends up being just 3. Again, that's one of those nice ones that ends up being a whole number or a rational number, so negative 2.5 is just itself. And then this last one here, 4 thirds. I kind of went a little bit out of order there, but I was trying to find the square roots first. 4 thirds end up being 1.3 repeating. So now that I've got all my numbers in decimal form here, I can plot these along my number line. Looks like my lowest one's actually going to be negative 2.5, so that's going to be right about here. So negative 2.5 is going to land right there. Done with that one. Negative 2.2. That's going to be right about here. I'm just going to make it a little higher here. So, and actually I should probably put what this really was negative square root of 5 is what they gave me in the problem. So that's what I'm going to put on my number line. Good, I got my 2 negatives out of the way. My other 3, let's see, it looks like my lowest one is 4 thirds right here. 4 thirds, that fraction. And then square root of 9 lands right on 3. And then square root of 13 ends up being 3.6, so a little farther down the way. Square root of 13, 3.6. So again, if I have you do some problems like this today also, ordering least to greatest, or just in general being able to take the square root and find out where they land on a number line, it's just to kind of give us an idea of even these irrational numbers. They have a place on the number line too. We can round them off to the nearest tenth and just kind of evaluate them like that and compare them to other numbers as well.